Good evening. My name is Justin Turner,
I'm Evan Olney. I'm Bradley Flores.
and we are the McNair All Stars, where our advisor was Dr. Clinton Lee, and our customer was North Carolina A&T State University, and our project was a digital pin board. So our project was designed to provide a better communication between student organizations and the Office of Student Affairs. So our customer being North Carolina A&T, they required us to have our board to be user friendly, energy efficient, having a high quality screen resolution, and a secure network for our board to connect to, as well as being physically secure so that nobody on campus could actually physically take it. So, in order to meet our customer needs, we first decided on a microcomputer that would best fit our project. And that microcomputer that we chose was Raspberry Pi. Then the group came to a decision to use a actual touchscreen monitor instead of using a touchscreen overlay on an actual monitor. It ended up being a little bit more expensive to get the touchscreen monitor, but it ended up being time efficient for on our sake in the end. And finally, we chose to go with two solar panels instead of one solar panel to help power our circuit because we found out that two solar panels gave us more voltage.
Okay, it's kind of hard to see on the video, but this is our design architecture. Um, the design was to have approved flyers to come into our system sent from the Office of Student Affairs, and that will come in through our network interface connecting to the internet, and then be processed by our flyer data control center and displayed on our touchscreen visual display. Now, we also wanted to have touch controls so that you can choose which flyer you're looking at, and anything else that needs to be displayed, you can see it there and you have control over it. So anybody walking by who sees the flyers can look at the next flyer, the past flyers. And also the Flyer Data Control Center itself will take down the flyers when they're too old, the event has passed, based on the threshold that's been set beforehand. Our power supply to power our system is designed to take two different power sources. Solar light being transferred into energy to charge a battery, as well as being able to plug into the wall and getting the normal 120 volt power. The power supply itself will make a comparison and choose which power it will use to charge the battery to power our system.
All right. Here we have our design implementation. This is covering the comparator circuit for the power supply, which is a hybrid system. We have two solar panels. One solar panel wasn't strong enough to charge the battery alone, and we have our transformer here converting your 120 volt outlet power to a 24 volt DC. The transformer first turns on the op amp and also turns on two signal relays. These relays give the op amp enough time to turn on without damaging the op amp. Once they're on, the op amp takes in the two voltages from the solar panels and the transformer, and whichever one has a greater supply will turn on the corresponding relay. Then whichever one has greater voltage will get sent through this relay directly to our battery charger. And in our testing results, we took the solar panel into a dim spot in the hall where there is a bulletin board right now, and tested to see what the voltage would be in that particular spot. That's how we were able to determine that one solar panel was not going to be strong enough. We noticed that the solar panel had an LED circuit on board showing that it's working. So taking that light out actually boosted how efficient the solar panel itself is. Once adding in the second solar panel in the hallway, we had enough voltage with the solar panels in order to charge the battery. In the lab, we had about 22 volts DC, which would be lower than the transformer voltage, but in this room, we have 25 volts DC, which means that with the right lighting, this can be a standalone system that doesn't have to be plugged in. But in those areas where it's not as bright, the hybrid system will come into play and keep the system going.
On the digital side of our project, there are a few other requirements that we had that included being able to download via a internet connection, as well as being able to connect to a secure access point. It would be easier to just have an Ethernet connection to a Raspberry Pi board, but to be able to have the board in any location and not have to be plugged into the wall, we found it to be better to have a Wi-Fi connection. So the Wi-Fi adapter for Raspberry Pi is also cheap like the Raspberry Pi, and it's able to pick up networks in its area. Through our test, we weren't able to configure it to the school's network because of the complexity of the network. Not that it's impossible, it just takes some more communication with the network administrator. But at other locations, we were able to successfully connect to a secure Wi-Fi network. As far as the flyer downloading test as well, we're able to have flyers on the board and display them, but we weren't able to download them through the internet connection. But we can get files from an internet connection through email onto the board, and that is also a secure connection, so we can monitor which email is sending this attachment, and so that we know that it's from the OSA.
So, in conclusion, our results show that it is definitely possible to power our whole system just off of solar energy and using indoor lighting, to where we don't have to have solar panels outside. We can actually have them indoors, have everything indoors, and it powers the whole system as a whole. It also shows that students will be able to easily use our touchscreen and go through different flyers for different flyers that are displayed that they can go to and see at that time. And finally, our results also show that it is possible for them to email a flyer to our board, and we're able to display that flyer because they approved it. And lastly, our results show that we're able to do this as a whole, and it's cost efficient. Everything that we bought here, we were still under budget, even with the touchscreen monitor was our most expensive thing. So if they wanted to implement this across campus, it would be very cost efficient for them to do so, and it wouldn't take much to do it. So that is our project. If you have any questions?
Oh, yeah. First off,
Thank you.
good job. Now, so you're saying that you can successfully send an email to the board. Is that what you're saying?
Yeah, with a network connection, we can send the emails to the board. The board will have to be configured to accept specific emails.
Okay. So that's the same way that if you were able to work this with the council of presidents or whoever it is, that's how they would that's how y'all would communicate through email?
Yes. Essentially, a student can send or bring their drive or give their flyer data over to the Office of Student Affairs. And once they have that flyer, they can decide to approve it. And if they want to approve it, then they can just send the email to the email of the board. And once they send it there, it should upload to a directory where all the other flyers are.
And if somehow a student is able to email to our board, then the board will recognize that this flyer hasn't been approved because it isn't coming from where it needs to come from.
Or
And
better yet, it just doesn't recognize the email at all, so it's not going to do anything with it.
Right.
So, in terms of, like you mentioned, the thresholds, I guess like if a flyer is supposed to be up there like 2 weeks or something, is that system, are you able to demonstrate that it's capable of, what would you call it, taking a flyer off?
I'm taking the flyer out of the directory.
Yeah.
We're not able to demonstrate it, but it's
in the
certainly
software?
feasible, that we can just, from our application, delete the image file itself from the directory.
So it would be automatic once you put the right constraints in terms
Yeah.
of dates and stuff?
You would have to send that with the email.
Okay. Well, yeah, it looks impressive. I think
All right. Well, thank you. Thank you for your time.